solving this question, t plus 2 raised to the power of 2 into t plus 3 then into t plus 4 equals to 480. And the question is to find t. What I've seen quite a number of people doing in solving this type of problem is to multiply out this left hand side. If we say we should do it this way, that's going to be a very long process. T plus 2 square, this is going to be t square plus 4t then plus 4, then bringing out this side, this part to its side, all this into t plus 3 then t plus 4 all equal to 480. To choose to multiply this all out like this is going to consume a lot of your time, because t plus 3 and into t plus 4 is just the same thing as t squared plus 7t then plus 12. Exactly, that's what I'm saying. Multiplying this out, then at the end of the day equate it to 480. Trust me, you don't want to do that for a 5 seconds interview question. That is why the word smartness comes in. To solve this under 5 seconds, I'm going to need to consider some things. I can see 2 here, then I can see 3 here, which means 2 plus 1, this means 3. Then if I had 1, 2, 3, of course I'm going to have 4. 2, 3, 4 shows that I have set of number sequence. Of course, that is sequence. I can also observe that these numbers 2, 3, 4 are in increasing order. That is another thing to observe. Of course, t is just one number that is just stable throughout. Let's assume the value of t is 1. If I have 1 here, which shows that in this parenthesis I just have 3. Then multiply by, because there's multiplication here. If t is 1 as said, which shows that I'm going to have 4 here, multiplied by, if t is 1 at the same time as we said, which means I'm going to have 5 here. And I still remember that we have 2 here. Actually, what I'm focusing on is that wherever the value of any number that is here, any number that is here, it's, I mean, they all have to be consecutive. In another word, this left hand side of my equation are just bunch of consecutive numbers in which if multiplied together is going to give me 480. Then another challenge is how am I going to suggest the 3 numbers which are consecutive if multiplied together is going to give me 480 under 5 seconds. I mean 5 seconds. Am I just going to be picking a number randomly? Okay, am I going to be guessing 2 times 3 then times 4? If this is square the first number, am I going to get 480? No, this is 4 times 3, that's going to be 12. 12 times 4, that's going to be 48. Or am I going to say, okay, that didn't work, maybe I should try 3 multiplied by 4, also consecutive. This is going to give me 180, which is not 480 that I am looking for. Trust me, no one wants to be guessing under 5 seconds. I don't want to be doing trial and error in this kind of situation. Therefore, I will rather use prime factorization. I just get the numbers that I really need straight away. Since I know what I'm looking for set of numbers which are sequence, increasing in order, and if I multiply them together, all is just going to give me 480, while the first number is raised by the power of 2. And I write 480 here, and starting with 2 goes here, that's going to be 240. Another 2, that's going to be 120. 2 goes in 120, that's going to be 60. 2 goes here, that's going to be 30. 2 goes here, that's going to be 15. 3 goes here, that's going to be 5. Then the final one, 5 goes here, that's going to be 1. So with this prime factorization, I've gotten the set of number I'm looking for instead of doing trial and error, which is going to consume most of my time. And I fish out consecutive number from here in which the first one is going to be multiple. I can see vividly that from here 2 times 2, that is 4. Also from here 2 times 2, that is another 4. I can see 2 multiplied by 3, that is going to be 6. While I have the last one, which is just 5. Therefore 480 is just a product of 4 square multiply by 5 and multiply by 6. Need to arrange it in ascending order. Time to equate my numbers, which shows that wherever that is here is just 4 to the power of 2. Multiply by wherever that is here in this binaries is just 5. Multiply by wherever that is here, t plus 4 is just 6. So that at the end of the day, when I multiply them all out, I'm still going to have 480. To find the value of my t as equated like this, I can now say t plus 2 all square equals to 4 square. And at the same time, t plus 3 equals 5 as is written. T plus 3 equals to 5. Also, t plus 4 equals to 6. T plus 4 equals to 6. Definitely the value of t is going to be the same thing throughout the 3 equations. But I'm going to start with this first one. I'm going to cancel this square. How am I going to do that? Looking for the inverse and multiply by the inverse of 2. That is, multiply by 1 over 2, multiply by 1 over 2. So 2 is going to go here, 2 is going to cancel 2, so this 2 is going to cancel each other. So if t plus 2 equals to 4, then if I subtract 2 from both sides, my t here is just equal to 2. And at the same time here, if I subtract 3 from both sides of the equation, I have t equals to 2 also. If I should check the last one also, if I subtract 4 from both sides of the equation, at the end of the day, t is still the same, 2. Therefore, t is definitely 2, my final answer. Also, we might need to verify this value of t, probably if t equals to 2 is actually correct or not. I'm going to insert this value of 2 here and see if this left hand side will be actually equal to the right hand side. If I say 2 here, then 2 plus 2, that's going to be 4. Then the power over that is square, multiply by 2 here also, 2 plus 3, that's going to be 5, multiply by, if 2 is here, 2 plus 4, and that's going to be 6. Then if I multiply all this together, it's just the same thing as what I have here, so it's going to give me 480.